I already have it, which is 3 over 2. So all I have to do is to take this guy and insert it here. So we end up having an integration from 0 to t for the value of 3 over 2 with respect to the t. Once you start substituting, you will have 3 over 2t from 0 up to t, which is going to come up to 3 over 2 into t. And this is the arc length. So I can say that now that s equal to 3 over 2 in t. This is the relation that's connecting the arc length with respect to t as a parametrized equation. Okay, very good. So he wants you now to find the arc length through the interval. He stated previously that t belongs to the closed interval from 0 up to 2 pi. So all I have to do is to start substituting instead of t by 2 pi. So I will go down and start substituting t equal 2 pi, and in this manner I will have the arc length, which is going to be 3 over 2 times a 2 over pi. The 2 will eat the 2, so it's going to come up to 3 pi unit lengths. And this is the arc length as I told you. So back again to our problem. It's really very simple. As I told you, we need to find the magnitude of r dash. Once more, this is r dash, the derivative of this function. We got the derivative and then squared every component from these components. They are going to come up to 3 over 2. Start integrating from 0 up to t, 3 over t, 2 with respect to t. Once you integrate, it's going to be 3 over 2 t. Now we have the function, the arc length function. If I want to substitute by 2 pi as exactly what we did, then we will have the arc length, which is 3 pi. For problem number C, he's asking you about the arc length function. This is why I told you, usually when they ask me about an arc length, I would prefer to have the arc length function, then I will start substituting. So once more, it's just the integration and the substitution by t. So it's going to come up to 3 over t over 2 times t. Determine the arc length parametrization. This is really very simple. This is really very important. Now, once you have the function of the arc length, just let me check that this part is covered in our camera to continue working with. Just in a second, please. Let me check. Yeah, okay, perfect. So all I have to do now, in order to get the parametrization of this curve by the arc length, I will use this formula once more. This is the connection between them. I will take this connection, which states that now I know that s equal to 3 over 2 in t, which leads to that t equal to 2s by 3. This is the main thing that I will use in substituting in the r function. So, but before we do this, there is also an important thing, that t runs from 0 up to 2 pi. I will have to find the value of s corresponding to these values. So all I have to do is to start when t equal to 0, I will start substituting here, which leads to that s will equal to 0. When t tends to 2 over pi, I will replace the t by 2 pi, so s will go to 3 pi. So this is the value of s if you are going to use the parametrization of s. So now all I have to do now is to start writing these values. So simply, as I told you, all I have to do is to start getting the parameterization. So r as a vector function, but in the arc length is gonna equal to replacing the t by this guy. So it's gonna be an s over 3 for the first component. For the second component, it's going to be a cosine of a 2 root 2, okay, of an s divided by 3. For the third component, it's going to be the sine, replacing the t over there by 2s over 3. So it's going to come up to 2 root 2 in s divided by 3. And this is the parametrization and the arc lengths that I told you about. So once more, okay, after verifying, of course, that s at 0 equal to 0, so if t equal to 0, s is going to equal to 0, so it's already verified. Now I made the parametrization using the s exactly as you can see on the whiteboard. Now he wants you to find the initial and the final position of particle B. This is really very simple. If you want to do this, I can use either the given form of t or using the s, it's going to be the same. So if I want to use the arc lengths formula and for the initial position, all I have to do is to replace the s's by 0. So it's going to be the first position is going to be 0, then I believe it's a 1, then I believe it's 0. So once you start substituting by s. And also it's exactly the same in here. So for t at 0, it's going to be 0, 1, and 0. This is t is going to equal to 0, and it will have the same results exactly, the same. And for the final position, means t equal to 2 pi. So here I will replace every t by a 2 over pi, But if I'm using the s, I will replace every s by 3 pi, and you will have exactly the same value. For this, it's going to be pi. So C for the first component, if I replace s by 3 of pi, I will have 1. If I replace s by 3 of pi, I will have 2 root 2 pi. Exactly the same as we are having here. So it's really very simple, and it's all coming together perfectly. Okay, for F, he wants you to compute the distance traveled by the particle P for t equal to pi over 2. So if I want to cover this, all I have to know now the distance. So let's get the arc lengths. Here we go. That's s equal to 3 over t. S equal to 3 over 2 times t. So at t equal pi over 4, all I have to do is just to make this value here times pi over 4, which is going to come up to 3 pi over 8. So if it was a multiple choice problem, it's going to be really very easy to have. Okay, what? Yes, it's a pi over 2. I'm sorry, he's asking you about t equal pi over 2, but I've substituted by pi. It's 4. I believe it's obvious this. For finding the location of the particle, this is really very nice. I want to find the location of particle B after it has been traveling a distance of pi of. So he's asking you when s is equal to this value. So once more, he wants you to determine the position of particle B after being moved to a distance pi over 2 root 2. So I'm going to use this value instead of s, using the parametrization in s. Or use this value to get the corresponding value of t. Both of them can work fine. I can use this value and start substituting in r of s, or instead I can use this result that s equal to 3 over 2t and replace s by pi over, here we go, pi over 2 times root 2, okay, times root 2, which is going to equal to the value of 3 over 2 times t. Get the value of t. Once you have the value of t, start substituting in r of t. This is actually what I did. Now I have t equal to pi root 2 over 3. I will take this value and I will start substituting in r. And this is how we are going to get the exact position of this particle at this distance. I want to thank you very much. As you can see, everything coming together nicely, and the values will you can determine easily the location of this particle. Guys, either you use the parametrization with the time or the parametrization with the arc lengths as we did. Since you are using the correct inputs for this formula to work the arc lengths, for this formula to work, which is the time, you will get the results that you get. By the end of this problem, we come to the end of lectures 4 and 5 and all the slides covering all of this. 4, 5, and 6 or so. Now I will, starting from the next lecture, I will start to go through slides 7 and 8, or the 2 lectures 7 and 8, which handles some topological definitions and then into the limits of multivariable functions. I thank you very much for watching this video. Please, for the 1000th time, it's not enough just to watch the video. You will need to solve each problem using your hand. Thank you very much, appreciate it, and best of luck for all of you. Thank you.